Okay, good morning, everyone. Welcome to online mini workshop on automotive and advanced transportation engineering. This is Tatsuya Mizukoshi, the director of Tokyo Tech Annex, Bangkok. Before starting, I will give you some notices. First, Q&A. Please write your questions in Q&A on the Zoom toolbar. Be aware that it may not be possible to answer all of your questions due to time constraint. And we have 30 minutes discussion time. In this period, if you have any opinions, comments during the discussion period, please use chat or please raise your hand. And today's video, this workshop will be recorded and later published on NSTDA and Tokyo Tech website. And this is today's program. Okay, then let me introduce today's chair, Associate Professor Dr. Precha Karim from Department of Mechanical Engineering, KMITL. Okay, so Dr. Precha Karim, please. Go ahead.
Okay, thank you. Thank you, Mr. Good morning, all participants. So today we have we can say the second of a mini workshop of automotive and advanced transportation engineering, and maybe the fourth workshop or the fourth mini workshop of TAIST-Tokyo Tech Annex. And we have today we have two speakers from Tokyo Institute of Technology, and one from NSTDA, one from KMUTT, and one from KMITL. So today we will start from KMITL speaker. So the first speaker is Dr. Mek Silomsak. He is a lecturer in Department of Mechanical Engineering, King Mongkut Institute of Technology, Lat Krabang. So his topic is diesel engines, particle emission, control science and technology. Okay, so please, Dr. Mek, start the presentation.
Thank you, Dr. Precha, for your introduction. Let me share my screen. All right, can you see my share screen?
Yes.
Okay. Let me adjust the screen a little bit. All right. Good morning again, everyone. My name is Mek Silomsak. I'm, as Dr. Precha said, a lecturer at the Department of Mechanical Engineering, KMITL. I am also a TAIST-Tokyo Tech alumni and also Tokyo Tech alumni. I stay in Okayama campus for 5.5 years. 5 years as a student's master's degree and PhD, and half a year as a postdoctoral fellow at the Hanamura Laboratory. So it's an honor to be invited to give a talk in this event. My today's talk is under the title of the diesel engines, particle emission control science and technology. But after I've given this title, I just feel that the emission control science and technology is too broad. So I want to be more specific into today's talk due to the time limitation. So I will talk mainly about the Dpf regeneration process and a role of nitrogen oxides on PM oxidation. Okay, but I will try to cover all the principle of the the particle emission control technology. Okay, let me start off by the background of this research. We can make a relationship between this research and the current situation in Thailand, PM 2.5 crisis. Okay, not only in Thailand but worldwide. The WHO stated that people in Southeast Asian and Western Pacific region countries experience the greatest burden of air pollution, meaning that it results in 3.8 million of premature deaths in 2016, okay, due to the exposure to the 5 particle of 2.5 micron or less in diameter. Okay, this is by WHO. So we can see how severe this problem is, especially in our country in the Southeast Asian. So our government launched a National Agenda Action Plan for troubleshooting of the dust PM pollution problems. Okay, this is announced by the Pollution Control Department of Thailand. Okay. So to make you see more clear picture of this problem, I try to take these pictures from famous newspaper from our country. For example, one from Siam Rat, one from Thai Rat, another is from Bangkok Post. Okay, on the upper picture, this is I'm not sure morning or evening of Bangkok, but what we can notice here is quite foggy. The scenery is not so clear as before. Okay, it's especially in the recent years. And the problem for this can be divided into 2 main sectors. The first one is agricultural sectors, which farmers burn their biomass products. Okay. And another sectors, especially in the urban area, in the city area, it is a transportation sector. Okay. The bottom left picture shows you an example of one. I think this is a mini truck. One of them just emit a lot of black smoke, and unfortunately, the how to say, the regulation in Thailand is not very strict about this. Okay. And this is one bus, but taking into account the number of cars in Bangkok each morning, we can see from the bottom right picture, there are a number of pickup truck, okay, because it is famous for Thai people. So each pickup truck can be emitted, can emit the black smoke, not much like these, but small for each of them can be accumulated. Therefore, there is no surprise that we get this upper picture after these and these combine. Okay. So to solve the problem, in my point of view, there can be 2 ways, okay, to pursue the zero emission technologies. One way is to use the alternative powertrain, such as electrified vehicles, or to use others technology like fuel cell vehicles, which they emit zero emission from their tailpipe. Okay, this is one way. And another way, if we want to keep using our internal combustion engine, we need to equip it with the after treatment systems. Then we can obtain almost zero emission as well. Okay, so this is my point of view about this. Therefore, we come to talk more about the after treatment system that I mentioned. For the internal combustion engine, they can be a gasoline engine, and diesel engine. But for our group, we are more familiar with the diesel engine. Therefore, we decide to pick up this part to share with you today. Okay. First of all, I mentioned about the main emission from the diesel engine. There are in addition to the carbon monoxide and hydrocarbon, which can be treated, there are particulate matter, or PM, and nitrogen oxides. And also another components in the diesel exhaust gas is rich oxygen content, because the engine is operated under the ultra lean burn condition, so that oxygen is available in the exhaust pipe. Okay. Although those toxic emissions in the developed country like in Japan or in Europe, there are many technologies available to take care of these toxic gases and particles. this bottom left picture shows the full system of the after treatment system, including D-cell oxidation catalyst, where hydrocarbon and carbon monoxide can be treated, okay, and nitrogen monoxide can be converted into nitrogen dioxide, NO2. And another equipment is DPF, where the black smoke or particulate matter can be trapped up to 98 to 99 filtration efficiency, okay, and selective catalyst reduction, where nitrogen oxides can be reduced into nitrogen gas and oxygen gas using ammonia. And then lastly, ammonia from the SCR was can be treated using the ammonia slip catalyst, ASC. So after passing this full system of after treatment, exhaust gas from the internal combustion engine can be cleaned, okay, equivalent to the exhaust, equivalent to the way we use electrified vehicles, okay, I can say. But unfortunately, in Thailand, we do not, our government still do not, how to say, implement these, the regulation to install these equipments in the diesel engine or diesel vehicle. So it to be improved in near future, I believe. To be more specific about the topic that I'm going to talk today, among numbers of equipments, I will focus on the equipment which we can use it to reduce the particulate matter emissions, which is DPF. Okay, it stands for diesel particulate filter. It's located in the exhaust system of the diesel engine. There are two main steps of the Dpf operation. The first one is the trapping process, okay, where the exhaust gas carrying the PM is forced to pass through a honeycomb structure of the filter with alternative end block, meaning that if one end open, another end is closed. If one end is closed, another end is open. Therefore, the exhaust gas and the PM is forced to flow through a channel and flow through a porous media wall. Okay, and then the PM will be trapped on the wall. Okay, this is the trapping process. And after the filter is clogged, after being used for some times, the filter need to be regularly cleaned through a regeneration process, where we increase the exhaust gas temperatures and then burn out all the trapped PM. Okay, and the below picture is just a schematic diagram of the after treatment system that I mentioned earlier to show you which gas to be treated after passing through each device. Okay, I will just skip. But the current issue in the DPF systems can be mainly two parts. The first one is the ash formation clogged in the filter after being used for some time. These ash are incombustible material, and it will, after each regeneration of burning or particles, it will be accumulated at the end plug or around the surface of the filter. It will limit the service lifetime of the filter. Okay, so movement of ash or movement of the soot during movement of the PM during the filter regeneration is to be studied. And another is about the regeneration process, which we will need to consume fuel to increase the exhaust gas temperature. Therefore, fuel consumption is an issue. Therefore, lower temperature of regeneration can be an interesting issue to be improved. So come to our research goals. Research interests of us are two main parts that I will talk about today is about the microscopic phenomena studies of the PM regeneration, the PM oxidation or DPF regeneration process. And another issue to be discussed today is about the relationship between each toxic gas. NO2 alone is toxic, PM alone is toxic, but they combine can be somewhat results in PM reductions. I will show you, but probably we need to go quick. Our research, this was done when I was in Japan, is that we prepare a sample, small size sample, instead of using the commercial size DPF, because we want to study the microscopic phenomena inside of them. Okay. We prepare the small size sample like this, and then we flow the exhaust gas through, and we can trap PM in each alternative channels. And then if we use the scanning electron microscope to observe each channel, we can see the microscopic picture, just like shown in the right-hand side, surface view of the vertical wall, horizontal wall, and this lower one is cross-sectional view of the vertical wall. And to continue, I want to introduce you some more information about the PM. This is about the hierarchy in rank scales of the PM. After we can see the PM accumulated on the filter substrate like this, we zoom in more, we can see the PM layers as a random shape. If we just pick up the small particles and then using the TEM to observe, it will shows to be the aggregate particles, nanoscale, looks like this. And if we zoom in more in red area like that, we see the smallest scale that can be defined as a particle called primary particle. Okay, so I just want you to get familiar with this hierarchy so we can show you some more results. First, we do the time-lapse visualization. We partially oxidize the PM trap on the surface of the filter and see how it's changed in the surface view, in the cross-sectional view. I will go quickly and show you the conclusions of our studies. Not only the microscopic in micrometer scale like this, we also pick up some primary particle to see the change after partial oxidation in the nanoscale. And we plot the particle size distribution against the number of particles counted. Like this, we can see that as a result, the particles tend to get smaller after partial oxidation. Okay, and this is the conclusion of our finding. After DPF is after soot is trapped on the DPF, each primary particle tend to get smaller, and then make the aggregate get smaller, and then make the cake layer of the aggregate accumulation get smaller. Chunk we call shrinking phenomena of the DPF after the regeneration. So we can conclude from there that shrinking phenomena is physical phenomena that happen during the DPF regeneration process. I'm not sure time allows, but I will try to continue a little bit more. That we also make a finding to understand the relationship between NO2 and PM, and we use the concept of the Arrhenius expression here. We can plot the mass loss of the carbon against the inverse of the temperature, and as a result, we get a line like this. Okay. And the slope of this line will be inverse of the activation energy of carbon divided by the universal gas constant, so that we can say the slope reflects the activation energy. The more this line parallel to the horizontal axis, the lower activation energy. The more this line parallel to the vertical axis, the higher activation energy, meaning that the reaction needs more energy to occur. So as a result, what we found that when nitrogen is included into the PM oxidation, it can lower the activation energy. Therefore, we propose it is a kind of catalytic effect due to the NO2, make the soot or PM oxidize faster when we have the NO2. Okay, and we also propose the way to study the nanostructure change of the soot primary particle when we add NO2. I think the time is limited. I will just go to the conclusions that we found. I made this animation for the conclusions, like if there is no NO2, oxygen tend to penetrate to the core of the particle and then burn out the primary particle from the inner. Therefore, we can see hollow looks like this. Okay, but and then results in carbon dioxide. But with nitrogen oxide, it will make the edge of the primary particle more reactive. We have the data, quantitative data for these conclusions. And then oxygen will not tend to penetrate into the core, but instead oxygen tend to be reacted with the shell of the primary particle, results in carbon dioxide. Okay, so this is our finding. We can say with NO2 addition, NO2 plus oxygen eat up short and tortuous carbon fringe structure at the edge side of the primary particle. Okay, so I will have to do the summary of my talk, sharing the idea with you today that I found that Dpf regeneration phenomena were initiated by shrinking of the PM cake layer, initiated by the shrinking of the primary particle. Okay. And the shrinking of the PM cake layer could be useful information to study the tracing the movement of the remaining ash residue in the Dpf, which that can define the permanent blockage, because the blockage of the ash can be a service lifetime of the Dpf, so that we can, if we know how the PM is moved, we know how ash is moved, probably we can decide to make the blockage less. And another summary of myself is to the role of nitrogen dioxide on this PM oxidation could be confirmed using the activation energy, which is chemical evidence, and another physical evidence is nanostructure change. So I propose that nitrogen dioxide play a catalytic effect on PM oxidation at the temperature lower than 500 degrees Celsius, chemical phenomena, and nanostructure change after adding the NO2 was that short and tortuous carbon fringe around the surface of the soot primary particle was disappeared. Therefore, this is a physical phenomena for the conclusions. Apologize for the too long presentation, but this is last slides for the reference of my talks, so you can find out more information from there. And acknowledgement for my laboratory in Japan, Hanamura Laboratory, Automotive Laboratory, my current laboratory, and also this is my contact. If you have any question later this presentation, just feel free to contact me. This is the end of my talk. Thank you, Dr. Prisha.
Okay, Dr. Nick, thank you very much for your interesting presentation. I think we still have around 2 minutes, 1 minute. Maybe I try to ask a short question in your presentation. You're talking about the nitrogen dioxide using for reduction of PM. So in your slide, I also found that the fraction of nitrogen dioxide is quite low in ppm level. So I'm not sure how much nitrogen dioxide can reduce soot in the case of too high quantity of soot, like our existing vehicle in Thailand, or is maybe suitable for high efficiency of the engine, like Euro 5 or Euro 6 system.
Yeah, well, what we are trying to point out, at the time we did the research preliminarily, that the range of the NO2 should be around 0 to 1000 ppm. So we just pick up the moderate number in the middle. But we can, even though it is the moderate, but we can see some effect due to the NO2. And in my personal opinion, from my experience, NO2 is more reactive as compared to the O2. In the low, especially in the lower temperature. So I believe that if the concentration of the NO2 could be higher, it is better. And these are also, this information can be useful in arranging the location of the equipment in the after treatment as well. For example, we need to have something that can convert NO into NO2 before the DPF, so that we can make a best benefit of nitrogen dioxide before it to be reduced into NO and O2. This is my opinion.
Okay, thank you very much.
Thank you.
So I think we will go to the next presentation, and for the other question we will discuss later after we finish the last presentation. So the next presentation is Associate Professor Dr. Masaki Yamashita from the School of Engineering, Tokyo Institute of Technology. The topic is lifting linearization and its application. So please, Professor Yamashita, start your presentation.
Can I see my slide?
Yes, Professor, can you show full screen?
Not yet. Oh, okay. I cannot make the full screen.
I think full screen of the PowerPoint. You can click full screen of PowerPoint.
Because the I extended the screen to so enlarging of the screen does not work.
スライドショーになりますか？
はい。
スライドショーになってないみたいですが。
そうなんですけど、スライドショーのフルスクリーン、拡張画面の方にはフルスクリーンになってるんですけど、
そうです。
ちょっと待ってくださいね。
Maybe slide show monitor change display. スライドショーのメニューにモニターがあると思うので、そこをどこに表示するかをチェンジすると。
モニター。はい。
パワーポイントのスライドショーをクリックすると、モニターってないですね。
モニターありますね。発表者ツールを使用するじゃなくて、
モニターでどちらで、なんていうか、フルスクリーンが表示されるかが変わるはず。
モニター1個しか出てないんだけど。
あれ、じゃあちょっとわかんないかな。ごめんなさい。
どうしようかな。時間がな。Sorry. Can you? No. ちょっと一回止めていいですかね。じゃあ。
Or we can use a PDF file also.
Is it better?
I think it's okay, this one. Yes, Professor, I think this is okay.
This is better.
Yes, we can see the full screen.
Oh, okay. So sorry. The title of today is Lifting Linearization and its Application. I'm Masaki Amakita from Tokyo Institute of Technology. And some of you are not so familiar to the lifting linearization. And first I want to explain what the lifting linearization is. And okay, so the actual system is actually the nonlinear, so we should deal with the nonlinearity of the system. But if we deal with the nonlinearity, the system becomes complex, and if we want to design the controller for the nonlinear system, and the computation burden becomes large, and sometimes it takes a long time to calculate the optimal control for the system. But here is an example here. Let's consider about the classification of the data. We have two kinds of the data here. In the left-hand side, there is the two groups of the data denoted by the cross, and the another one is denoted by the circle. And the another set of the data is shown in the right-hand side here. And if we consider about the data in the right-hand side, maybe we can classify by the line like this. But if we want to classify, distinguish between the data by the cross and the circle, we should use this kind of circle. And that circle is a nonlinear function, so we can not use a affine function to distinguish this data. But if we add a kind of the distance as a third element of the data, we can have this kind of the plot in the right-hand side here. At that time, in order to distinguish the two group of the data, we can use hyperplane as shown in this figure. So from this example, we can learn that if we consider things in a higher dimension, the things becomes easier, or the affine function becomes very useful to deal with the data. And if we consider about the identification of the system, usually we want to have a low order system. But if we consider about the behavior of the dynamics in the higher dimension, the things maybe become easier. The idea is not so. Next, I want to explain about the dynamical system. Let's consider about this simple discrete and nonlinear system. The first dimension is 2. And the x1, the state vector consists of the x1 and x2. And the dynamics is given by this equation. And if we add new state, G3 as a x1 square like this, and then if we consider about the time advance of this G, G of k plus 1 is given by this right-hand side, of course, and then this can be represented by the further right-hand side, this one. And then this right-hand side can be expressed as mu G1 and mu G2 minus lambda G3, mu square G3. That can be represented by the final right-hand side here, like this. This means that G of k is equal to phi times G of k, and phi is a constant. So if we add a new state variable, this dynamics can be represented by linear time invariant system LTI. And this example shows that. So if we consider about the dynamics of the system in a higher dimension, maybe dynamics can be represented as a linear system. And we call such a linear system representation of the approximation as a lifting linear representation of the approximation. And if we can have that kind of linear representation of the nonlinear system, we can apply the method for the linear system. Maybe we can define the oscillation mode of the nonlinear system, and we can utilize the design methodologies for the linear system for the nonlinear system. And also, nonlinear model predict control is converted to the linear MPC. And if we can use a linear model predict control, we can attain the first computation, and we can attain the global optimization. And also, if we want to apply the stochastic nonlinear model predict control, it's very hard to be solved for the nonlinear system, but it's easy for the linear time invariant system. And as in this example, if the system can be represented as a linear system, we can have many advantages. This kind of idea actually is not new. In 1931, Koopman showed that if we embedded the dynamics of the nonlinear system to the infinite dimensional space, the behavior can be represented as a linear system. And so the Koopman showed that kind of fact almost 100 years ago. And we rediscover that kind of nature maybe after 2000 years. And nowadays, this kind of lifting linearization is very active research area in control community. And there are several methods for the lifting linearization. And one is a dual phase linearization. And so maybe I don't have enough time to explain about the detail of the dual phase linearization. But this is actual the approximate linearization using the Taylor series expansion. But instead, if we consider about the Koopman operator U, which is defined by this equation, if we consider this kind of the nonlinear system, then we can show that this Koopman operator has a linearity for the nonlinear system. And the Ari Asada from MIT proposed a dual phase linearization for the lifting linearization. At that time, in his method, he utilized the natural linearity of the physical system, and also he employed the nonlinearity of each element as a second class of the state variables. At that time, we can obtain this kind of the linear system for the nonlinear system, where the x is the original state variable, eta is a new state variable for the nonlinearity of the system. Then we can obtain this kind of the linear expression. But if the dynamics of the system is known exactly at the time, we can apply this DFL. But if there exists some uncertainty in the system or the parasites, we cannot directly apply this DFL. So we extended this DFL to as a robust DFL. At that time, we introduced third kind of the state variables, which consist of this kind of the sim-plate spline basis function. That is a kind of the introduction of the kernel tree. And then the system can be represented by as a this linear time invariant system, where the gamma is a set of the third class of the nonlinear state. And if we apply the robust DFA, and if we consider about this kind of nonlinear spring system, we can accurately predict the behavior of the system by the LTI expression. And also we apply the same idea to this kind of the VPP charging or discharging system. At that time, we consider about the electrical vehicle, and we want to charge and discharge a large group of the electrical vehicle. At that time, we want to consider about the SOC and the damage of the battery and the line voltage of the network. And we want to reschedule the optimal sequence of the charging and the discharging every 3 minutes. And we want to predict the behavior during the 24 hours and the sequence of the charging optimized. And this is the criterion function and the dynamics of the SOC and so on. And in that cases, the equation of the battery deterioration can be expressed by this kind of nonlinear equation. But this nonlinear property can be approximated by this kind of square term function. Then at that time, we introduce the SOC square as a new state variable for this equation. And then we identify the coefficient A1, A2, B1, B2 from the actual data. And then these, we determine the two sets of the A1, A2, B1, B2, and then they are switched to a region according to the SOC. And we compare the performance of the proposed method with the Taylor series expansion and the CGMLS, which is very famous nonlinear MPC method. And we just, first we consider about a very toy problem. At that time, the computational time becomes like this. And of course, the Taylor series expansion gives a shorter calculation time, but the criterion function is the worst. But if we consider about linear lifting linearization, at that time, the criterion function is compatible to the CGMLS method. But if we consider about 30,000 electrical vehicles, that is a practical situation. At that time, CGMS could not solve this large size of the optimization. But we applied the proposed method for the same problem. At that time, the computational time just less than 1 second. But if we use a nonlinear solver for the same problem, at that time, the computational time is something like that. So the computational time is shorter than the 10,000 factor. So if we use the system lifting linearization representation of the system, we can have this kind of very high-speed computation. And but even though if we use a robust DFA, still the dimension of the system becomes very high. Or if we consider about the control input for the system, it's very difficult to obtain the lifting linearization representation of the system. At that time, we apply the bilinearization of the model. At that time, if we can have the bilinearization of the system, we can effectively apply the linear model predictive control for the nonlinear system. And I want to skip the detail of the method. So if you are interested in those kind of methods, please refer to the reference here. Okay, so I want to jump to the conclusion and the future works. I briefly introduced the lifting linearization in this presentation. And then I show the effectiveness of the lifting linearization for the discharging or charging of the electric vehicle whose size is 30,000, which is a practical situation. And also, I mentioned that if we use a bilinear linearization of the nonlinear system, we can easily apply the linear model predictive control for the nonlinear system. And the future work should include this kind of verification of the effectiveness or robustness of this lifting linearization for real application. And also, we should improve how to select the auxiliary variables, the added state variable. Okay, thank you. That's all. Thank you for listening.
Thank you, Professor Yamakita. Thank you for interesting presentation. Now I just note that we have Q&A in chat box of Q&A. Maybe I will summarize the question after the last presentation from our workshop. So now I think we have no question to Professor Yamakita. Okay, thank you so much. So can we go to the next presentation? The next presentation is come from Department of Mechanical Engineering, King Mongkut University of Technology, Thonburi, by Assistant Professor Danai Hao Harihan. The topic is development of autonomous vehicle based on robotics operating system. So please, Professor Danai, start the presentation.
Okay, thank you. And I will share my slide. It's okay, Professor Prisha?
Yes, we can see your slide clearly.
Okay, thank you. Good morning, ladies and gentlemen. Today, I would like to present development of autonomous vehicle based on robot operating system or ROS. My outline is about the introduction about the autonomous vehicle, automotive system, and robot operating system, and how to design or develop the autonomous vehicle system design based on ROS system, and simulation and experiment using the ROS. At first, I think many people know about the autonomous vehicle, and it's become to realize. Nowadays, the Society of Automotive Engineering has published the SAE level of driving automation from level 0 to level 5, which define the level for autonomous vehicle relative to the ability of autonomous function. For example, SAE level 0 is the vehicle just install only the warning system, such as the automatic emergency brake, blind spot warning, or lane departure warning, something like this one. And to perform the autonomous function in the vehicle, it requires some specific control system and install extra equipment for measure the environment, such as 3D LiDAR, IoT device, and other environment sensors. Then in the autonomous vehicle is have many tasks of control system, then it's very, very difficult to develop in the one program, which lead to the developed by some method to class each control to the small size and combine it together later. So nowadays, the commercial autonomous vehicle, which we can see in the market, is like Tesla has a Tesla Autopilot, which is classified in SEAE level 2, which obtain the centering, lane centering, traffic aware, cruise control, automatic lane change, and self parking. So in this one, it means that we have to control the steer wheel and acceleration pedal in order to perform this autonomous task, which is classified in level. So this is classified in level 2. Moreover, the Apollo Go, which developed by Baidu from China, and Waymo Robotaxi from USA, is blessed to develop the self-driving taxis in reality. So nowadays we can use the Apollo Go in parking, which run for service as we set the target position, and the vehicle can find the route, is planning, path planning, and trajectory tracking, follow the road to the target. If we see back to the history of development of autonomous vehicle, we can see that it's not only the electric vehicle which developed for autonomous vehicle, but also the ICV vehicle is also, such as we can see it, but in the DARPA Urban Challenge, is this challenge has ICV vehicle which was developed by install the extra sensor and perform to the drive in the urban road, like you see in the bottom picture, like this. And since 2014, Formula Student competition will have started to the EV competition, which is for driverless vehicle. And next is Indy Autonomous Challenge, is held since 2018. This challenge is for develop the Formula One vehicle to competition the speed and performance for with it's also autonomous vehicle. If we see to the architecture of internal combustion vehicle or ICV vehicle, it obtains several devices in order to perform the vehicle, such as the engine ECU to perform the engine, and transmission ECU is to perform the transmission system like a gearbox and acceleration pedal control to check the status of acceleration pedal. It may have this is grouped as the drivetrain system at a lower this one. This is obtained at the drivetrain system, which communicate by CAN bus. And other one is for the chassis control, like window lift control or miller or door module is also communicate to see the status and perform under the CAN bus communication. And other thing is for infotainment is like a GPS, radio, like this one. So we can see in the vehicle architecture of ICV vehicle, separate the system to be the small or subsystem for engine, for transmission, for chassis, for infotainment, and connect it together under the CAN communication. And after that, is have a OBD2 port, which is required by the regulation that all 1997 and newer passenger car and trucks have to install OBD2 system, so that it's main communication for sharing the data. And inside the OBD2 protocol is also the CAN communication system in the OBD2 too. Then for this architecture is have a small size of or subsystem in the vehicle. If we compare this one with the ROS or robot operating system, it also have very similar. In the ROS system have we call the ROS master to register the name and of the ROS node, and ROS node present like a subsystem in the robot or vehicle, and each node is have a communication by a message. So the message is like some CAN protocol or other protocol is also support. Then to design the autonomous vehicle using the for the autonomous using ROS, we can see the conventional type of autonomous vehicle, which developed based on the conventional type that, for example, is Anyway autonomous vehicle, which is developed based on internal combustion vehicle in 2007. The several sensors like such as stereo camera, GPS antenna, and 2D LiDAR, IMU, and some actuator like electronic throttle, electronic steering, and electronic brake installed to the vehicle. Then we can see the architecture in the left bottom, that every sensor is send the data to the single main computer to process for localization and motion planning and part planning, and then send the command to the ECU to perform the engine and electric and powertrain on the next. So the main computer is like a very big program and complex. Then it's not so many developers easy to develop the autonomous vehicle in that time. If we see the just only the main task to drive the vehicle on the part that we decide, if see like the conventional navigation control system like this one, we have a design part as the input to the system, and have a motion planning system to plan the motion of vehicle and observe the position of vehicle from the localization system. And after that, send the data to the trajectory tracking control to derive the input to drive the hardware control like ECU and perform to the drive the vehicle. So the vehicle will be moved and sensor receive the data and feedback to localization again. This is only general or conventional navigation control system for a vehicle. If have a obstacle avoidance or other thing, is the control system is more complex. If we compare this one with the ROS design, that is we refer to the Formula Student Driverless race car. It's also installed a similar sensor and have a architecture right as you see in the block diagram in the right hand side. The brown is the bottom area is hardware of vehicle. It's installed like the wheel control, steering control, and brake. It's general to perform the vehicle. That's right. And have they receive the command or decide position or decide speed of vehicle from the ROS system in the blue blocks like this one. So the system can be separate to the subsystem, and many developers in computer engineering or computer science or maybe focus on the upper block like this one. So nowadays, many developer is focused on the algorithm to navigation tracking and find the algorithm to derive to decide the part of vehicle and more intelligent function, which develop on the upper block. And for the next, the architecture will be separate as the subsystem. We generally is the separate from as the vehicle node, which is ROS node. Inside of this is have a control system for control the steering and powertrain, and have the sensor module to get the information of vehicle and feedback to the intelligent node, such as the trajectory tracking, path and motion planning, and localization and visualization as the sensor message or geometry message. And after process in the intelligent system, will feedback to the vehicle node again as the command message to perform the motion of steering and powertrain. For the ROS system obtain the ROS 3D visualizer in order to help us or help developer in order to see the visual or vision of the vehicle that as shown in the left side. On the left upper picture is a RVS package. It is used to render the vision of the vehicle, including the homogeneous transformation in order for creating the 3D mapping builder. We can recognize the 3D mapping and find a good way to perform the vehicle. And another one is MapWiz package. It focuses on the large scale to the data like Google Map or street map like this one, and localize the vehicle into the global localization. Because when if we apply with the robot or small vehicle, it may use only the RVS in order to create the map. But if we have a lot of data, that is not easy to record the 3D map. That is why MapWiz developed that. And then to the simulation or experiment, if we try the autonomous vehicle using the experiment, only the experiment is have a very dangerous. So we want to simulate the motion in the virtual environment, like using the RVS package or other third party software like Kala. Kala is a software simulator. It can couple with the iOS by some message, specific message between the Kala program and iOS program. The program can publish and subscribe the iOS message. This can use to import the data from visual sensor in Kala simulator and feedback to the iOS in order to perform the vehicle. So, and I have 2 cases. For the upper case, it's like my experiment that we try to perform the vehicle and avoid the orange car, which is front of vehicle, like this one. This the black car is trained by DQN algorithm to obstacle avoidance. In some cases, if we not train the vehicle to intelligent enough to avoid, maybe have a crash in simulator. So that is point that if we try with experiment, it may have some accident. And case 2 is I try to train the black vehicle is avoid accident when the orange car is come to the black vehicle lane. Yes, this is all for my presentation. I present about the good point. What is between the vehicle system and iOS system has similar. So, and introduce some package of iOS in order to practice and simulate the autonomous vehicle. So the summary, the advantage of iOS system for autonomous vehicle that it have a lot of library for autonomous vehicle, which is we can access the sensor and have a pre-process for reduce the noise and combine the sensor as a sensor fusion, and it's easy to connect to the motor controller or other microcontroller unit, and also have the visualization tool to monitoring the visual of vehicle in comprehensive manner. That is advantage, but it also disadvantage that when we separate the system of vehicle.
Dr. Danai, sorry, I think we have to a bit speed now.
Okay,
a bit
this
delay.
is the last one. Sorry.
Okay. Okay.
If one node of iOS is failed, the whole system goes down, and the package of communication package of iOS is standard, so everyone can access the data. So it have a low communication security. Okay, that's all for my presentation.
Okay, thank you.
Thank you,
Professor Danai. Very interesting. So now, please, Dr. Meg and Dr. Danai and Professor Yamakita, check the questions in Q&A chat and also in the general chat, and then we can discuss about the question. We will give you a time for the answer after the final presentation from Professor Tanaka. Okay, I want to go to the next presentation. The presentation from Dr. Manop Masomthop, National Energy Technology Center, NSTDA. The topic is disruption and transformation of electric vehicle technology in Thailand. So please, Dr. Manop, start the presentation.
Can you see my slide?
Yes. Yes. Okay.
Okay. Okay. Thank you, Dr. Pisha, to introduce me. Good morning, everyone. My name is Manop Masomthop. I'm a Thai-Tokyo Tech alumni, and also I'm a researcher from National Energy Technology Center. Today, I would like to talk about the topic disruption and transformation of the electric vehicle in Thailand. This means how Thailand can survive for the electric vehicle. And this slide shows the development of the automotive industry in Thailand. The Thailand start to have the policy about for the ICE car for the localization policy in 1970. And then we have many provision for the pickup, big bike, motorcycle, eco car, and third car, and also about the CO2 tax. And in about the 2017, Thailand begin to support the XEV. XEV is mean not only about the BEV, but also for the hybrid vehicle also. And for this slide, show the opportunity for the electrical electric vehicle in Thailand. For the e-bike, yes, we can do. For the e-motorcycle, we can do. And e-truck, yes, Thailand can do. E-bike, Thailand can do. And also e-bus. But the problem is only the e-car. E-car, we have the FTA issue. Thailand, Thai company are not interested in the e-car section due to the FTA issue between ASEAN and China. Import duty 0%. And if we talk about the e-bus, many companies try to build the e-bus. Some companies are using aluminum body to reduce the weight of the bus. This means for the e-bus, we use small battery. It's packed, and it means the price of the e-bus is cheaper. Yeah. And this slide shows the structural tax in Thailand. When you compare between the import product and local product, sorry, and then you see in this block, you will see that for the import duty or custom duty between China and ASEAN is mean Thailand also 0%. And if we talk about the Japan and Thailand 20%, and Korea and Thailand 40%, and from the another country such as USA, European country 80%. Why does it mean why Thai people don't have enough money to buy the car from the European country? And if you talk about the local production, and we have only the excise tax, and then if the company are supported by the BOI, the tax from the 8% to be 2%, but it's cheaper. For the import product, we figure 8%. Yeah. And then we have local government tax 10%, and then we have the value add tax 7%. This means, and this slide shows the example for the calculation. I compare 3 countries, and the import car, electric car from Japan, and electric car from the China, and production in Thailand. And for the cost of the car, if the cost of the car is 1 million baht, it's 1 million baht. Yeah. And then CIF is mean, C is cost, and I insurance, and F is a freight. When you ship the car from Japan to Thailand, you have to pay the insurance and freight in total cost about this. And if in China about this, but in Thailand only the 1 million, because we don't need to ship the car from Thailand to Thailand. Yeah. And if you talk about the custom duty, yeah, this is really important. As I showed the last slide, 20% when we import the car from Japan, yeah, like this, you have to pay the tax more than for the custom duty, 200,000 baht. But from the China, 0 baht. Yeah, from the product in Thailand, 0 baht. And then for the excise tax, again, and this look like the again, and then multiply the excise tax about this, and this no custom duty if you import the car from China. And this is if you support by the BOI, you will get the reduction from the 8% to be 2%. Yeah, and this is a local government. This local comment is fixed. Yeah, we cannot change anything for the WACC. The WACC multiply all of tax that we calculate before. Yeah, in the total cost does not include the profit and the corporate tax. And the car from Japan based on the cost 1 million baht. About this 1.5 million, and from the China 1.2 million, and from the Thailand 1 million baht. The problem is, in reality, the cost of the car is not from the China, is not 1 million. Because the car from the China is cheaper than the car from Japan and the car produced in Thailand because of the mass production. This is the reason why the Thai company are not interested in e-car. E-car is mean a sedan car and SUV, yeah, hatchback also, yeah, because of the import duty 0%. Okay, and then how Thailand can survive? How to transform the electric vehicle technology in Thailand? In the private section, private company try to transform the own business from the ICE product or ICE part to be the EV products. And then for the EV technology, it looks like you can import smaller battery from the different country, and then you can assemble. In Thailand, it means we have many startup company open in Thailand, and also DIY like the hobby. Yeah. For the government section, the government to have many policy to support the Thai industry, and also for the buyer to buy the new car that is the electric car. And for the research center to support to the Thai industry for the EV product development, and for the technical college and university try to increase the students to know about the EV technology. And for the standard testing institute, try to invest many equipment to test the product parts from the Thai industry for the safety and also for the international standard. And in this slide just show about the standard that we have. For the R100, we have already reviewed 6. This for the standard testing for the 3-wheel and 2-wheel. Yeah, we invest already. And then another is not standard about the flat testing. For the flat testing, it's not to follow the standard, but you have to understand that in Thailand or in Bangkok, we have many problems about the flat situation. And then if you design the car and if you build the car to sell to the customer, you have to concern about the flat situation also. And also for the performance and development, and NASA invest to install the equipment for the battery motor testing like the motor dynamometer can take the power more than 300 kilowatts, and about the torque is more than 1.8 thousand Newton meter. And also, and for the motor, for the dynamometer, for the motor, and then is not over than next February testing. And for the end of this year, and then it's not over than the end of this year, NASA will have the hardware interlude for the BMS, for the VCU, and for the motor controller, and for the charger analyzer. And also now we have the battery tester for the cell and for the pack, and also for the electric motorcycle dynamometer. Why we have the electric motorcycle dynamometer? Because many motorcycle manufacturers in Thailand invest a lot of to build the electric motorcycle to sell them to the customer. And this slide showed our researcher in my laboratory, and I have about 4 areas. The first area is the cooling system, and second area the safety, and third area is the production, and the fourth area is the EV system. For the cooling system, we try to find a new technique to estimate the heat generation from the battery cell. Why we would like to know? We cannot design the cooling system if we don't know exactly the heat from the battery cell. And then after that, we do the research for the air cooling system, liquid cooling system, and also refrigerant cooling system. And for the safety, and nowadays we focus on the lithium battery fire suspension. You have to understand that now many products from the a lot of accident for the lithium fire. And then with the battery thermal runaway prevention system, IMT lead from the battery pack to the car body. Yeah. And then we try to design and understand about the algorithm for the battery management system BMS. For the production, and we try to find the good solution for the battery pack design to reduce the cost. On the spot welding tech, I can say for the spot welding technique in my lab is really expert, because we focus in this is cheaper than laser technique, and also wide body technique. And also we try to study about the new material, like the material selection for the battery pack. For the EV system, we did hybrid system, like to use a different battery cell, LFP and NMC together. And sometimes we use a super capacitor and battery together. And then we have 2 minutes about the system. And then to develop the powertrain calculation software for the EV. This is really important for the Thai industry. As you know, the commercial software to calculate the powertrain is really expensive. NASA tried to develop the powertrain calculation software based on Excel. It means everyone, student or the people in the company can use the software, because they have already the Excel software in the computer. And then we help industry to do the E conversion. And this slide just show about the some part of our research. And when you see the green box, this is electronic device. BMS, master BMS or MCU, and the IMD and VCU, all of them, the green box is a electronic device. And then NASA collaborate with the ECU shop to build the product. The product should be cheap. We don't want to import this product from another country. Because if we import BMS or master BMS from another country, it means when we would like to modify the electronic device back to that country, but it's really take time. Maybe the company in another country will know the secret knowledge of the battery manufacturer in Thailand and also car manufacturer in Thailand. And then we try to this is a prototype. I think it's not over. Then next year we will have the commercial product. We finished to build the prototype already. Not only about the BMS, we have to build the BMS tester because we need some device to test our BMS. And also the ECU shop developed the VCU and HMI to indicate the system between the battery pack, between and the motor controller, and also maybe system. Yeah. And for the safety, this slide just show when the battery pack are fire. And I can show the slide. This is only single cell. It looks like a bomb. It looks like a bullet. Only single cell. The temperature of battery is increased and increased until about the 100 degrees Celsius, and then the voltage of the battery is dropped quickly. And then we wait until about the 120 degrees Celsius. Some gas like it begin when from the battery cell, the gas here. And for this zone, it looks like a thermal on the way. And until the 180 degrees Celsius, the battery cell is explode. And then we try to find the way how to stop the fire due to the battery cell explosion. And this picture just show about the damage only one cell. And this cell can transfer the heat from the first cell to the second cell and third cell and fourth cell. It means this cell can make the second cell heat up, and then and the second cell can explode. And then after that, the third cell will explode. And then how can we stop that? We try to install many sensors like the temperature sensor and voltage sensor, pressure sensor in case battery pack is a closed system. And also we install the gas sensor such as CO, maybe hydrogen sensor to monitor when we have some gas from the battery cell. The first step, we know that if we have some gas, when the gas is look like fuel, when the fuel mix with the oxygen, and then we have some heat, and the inside can look like the combustion starter to feed the nitrogen or argon to remove the oxygen first. And then if the battery cell still burn, we feed the water to the battery pack. And then why we feed the water? Because we would like to reduce the temperature of the the first battery cell. If we can reduce the temperature down, it means no heat to transfer to second and third and fourth. That means we can stop the fire from the battery. Cannot use the electricity, but you have to understand that if you talk about light and Newton and ground, and when you use the water, the water attack catch the line, and then the electricity can flow through the water, and then the electricity can flow via your body to the ground. But for the battery pack, you have to understand that positive side and negative side is in the battery pack or in the car. When we use the water to stop the fire, it means maybe some short circuit in the car, but it's not no electricity flow to you. Yeah. Okay, for the last slide, for the EV conversion, and for the EV conversion, we talk about the EV conversion. It's not electric new EV. We have used this logic. If we have the motor has the dual charge motor, real and front. For the real, we can use to die the own system, like the another auxiliary system, to die the compressor air, to die the steering pump, to die the water pump. Yeah, like it. Because it means we can keep the own part. We can reduce the cost for the EV conversion. If we have only single shaft, we can make the link from the shaft to be the front, and then drive the own system again. But if another way, you can use a two motor. The big motor or first motor, you can drive the gear, and then you can use this motor to drive the car. And the second motor, you can use to drive the another auxiliary system. That's all of them of my presentation. Thank you for your attention.
Okay, thank you, Dr. Manop. Very interesting. So please, Dr. Manop, check the question in chat box. Okay, we will go to the last presentation of the today mini workshop. The presentation is come from also School of Engineering, Tokyo Institute of Technology, Associate Professor Masayuki Tanaka. Okay, please, Professor Tanaka, start the presentation, please.
Thank you for introduction. I'm Masayuki Tanaka from Department of System and Control Engineering, Tokyo Tech, Japan. Today, I'd like to talking about gradient-based image processing. Let's start. What is image processing? You may have, all of you already have some experience to use image processing or image filtering like Instagram. Image processing basically converts input image to some of these kind of image processing results. This is example of image processing results, the name of filter and filtering result. There are a lot of or so many filters, and this is some of them. And I'm not sure the reason why they put the naming of Japanese for this filtering, but there are so many filters. The purpose of the image processing include denoising to reduce the noise, color correction, good to get the good color, low light image enhancements, detail enhancements, and so on. The purpose of image processing is mainly for human. Something like this one is to generate nice image. This is for human, but not only for human. Nowadays, we want to process or apply image processing for machine or AI. Here is a typical image processing. based on intensity, called intensity-based tone mapping. This is input image. The horizontal axis is input intensity. The vertical axis is output intensity. The higher intensity represents the bright pixels. In this tone mapping case, for example, the 50 intensity converts to roughly 150 intensity. It means looks bright. The other hand, if we apply this kind of tone mapping, the 150 intensity is roughly 30 intensity. Then we will have looks dark intensity. This kind of relationship is very basic of image processing. If we want to get the bright image, we need to apply this kind of tone mapping. Next, let's move on a little bit about mathematics. Here is an example of function of two variables. This is image, but we can consider image is a kind of function of two variables. Here is the image, the contour, 3D plot. This is the information of all of them is equals. And also, even if this is a 3D plot of the mathematical function of two variables, contour, this is the image representation. So we can consider an image is a function of two variables. Next, let's consider about the differential and integral. You may already know about what is a differential, but the differential represents the slope or gradient at each point. The gradient information is sometimes we can get the good information from gradient map or gradient. And this is an important relationship. The gradient can be returned back by integral. If we apply integral to gradient the function, we will have original function. That is a good relationship. And this kind of mathematical is used or related to even for the industry product. The left-hand side is product A and product B. I hope through the Zoom, you can see the border here. But in the product B, there are no border. The reason is related to the derivative or gradient. The first derivative of product A is continuous. So if you touch this product, there are no discontinuity. But second derivative of product A is discontinuous or not continuity. So we can see some border here. While the product B, it has a good property. The both of first derivative and second derivatives are continuous. That's why we cannot see the border. Maybe the many of people think the product B looks better. Okay, so differential or gradient information is also related to the industrial products, I think. Let's go back to the tone mapping. My question is, what happens if we apply this kind of manipulation in image gradient domain? As you see the previous slides, the gradient information is very sensitive to the human visual system. So it might be good to apply this kind of tone mapping in gradient domain. That is a simple idea. So let's consider we have input image. If we apply integral of this kind of original or a plane gradient, we will have exactly same output image. So next, what happens if we apply the tone mapping for this kind of gradient? This is a simple example of tone mapping in gradient. We consider the small gradient is a kind of noise. Then the moderate size to clarify the image. Then we have this kind of image. This is I will explain about this range constraint here. Just now is sharing something happen in the network. Are you able to see my screen, or do I need to screen sharing?
Okay, please reshare again,
Okay.
Professor.
Now I guess.
Okay. Yes.
Okay, thank you. Here I will show the two examples of image processing in gradient-based filtering. Edge preserving smoothing. Let's say that this is a smoothing, detail enhancement. So you can see that this is maybe this is a fake far. If we apply strong effect, we can see the smoothing, but still have some in preserving edges. Here is an example of the detail enhancements. The detail information is enhanced to apply strong effect. And also we can combine these two. So the horizontally, we apply the strongest edge preserving smoothness. The horizontal direction is detail enhancement. So here is very strong smooth enhancement and also detail enhancement. So you can see this fake far region is smoothed out, but still have the clean edge. And then this kind of gradient-based image processing has interesting property. This gradient-based image processing can reproduce the illusion. So this is a very famous illusion for human. The region A, region B, you may think region B is brighter than region A. But actually, this intensity of these two regions are exactly the same. But when we apply the gradient-based image processing and this kind of simple tone mapping in gradient domain, then integral out, we'll have different image. So image also think region B has brighter than region A. Actually, here is a result. The intensity value is exactly same of original image. Even so, the human perception B is brighter than A. This is illusion. But if we apply the image processing, gradient-based image processing and very, very simple tone mapping, the computer think that region B is brighter than region A. This is one of interesting property. And also the low light image enhancement, this is one of critical application. Please imagine in autonomous driving, in the night scene, we need to improve the image quality of low light image scene. So here is our result. Even if the input image is very dark, we can apply the gradient-based image processing, then we will have this kind of good image. Of course, this kind of application already many researchers studied. There are some examples of another algorithm. This one is our result. It depends on the situation, but I hope our algorithm or our result looks nice. Here is a different example. For example, this one is also another example, another algorithm. It looks nice, but you can the characters on the book is white out. You cannot see any information from this region. But from ours, we can see some information. There are some characters, sentences. Not exactly, we don't know what kind of sentences, but there are something. This is a good property of ours, I think. And here is another example. There are very, very low light image. This is in a tunnel. It's maybe dark cafe or something in a wood, even in a building. If we apply our low light image enhancement, we can get good results. So this kind of application is already published in web. Here is demonstration of example. This is an input image. We can apply our algorithm. You can see the bright image. And also we can apply the detail enhancement. You can see. And also the smoothing. It looks like somehow the painting. But please remember, this is original input. We cannot see the detail in the dark region, but just apply a proposal. We can see the nice result. This is the application or demonstration of our algorithm of image processing. And this application is already uploaded. So if you want, you can use by yourself. All right. Then I will explain a little bit about the mathematics or algorithm. So first, the input, we extract gradient information from input image, then apply manipulation. Manipulation means enhance or reduce or something like that. Then apply gradient integral. Hopefully we will have the good result, but there are some problems. Because before integral, we don't know the intensity range of intensity, because we apply some manipulation. But usually the intensity range of image should be within 0 to 255. But we don't know if we apply some enhance in gradient domain, what kind of intensity range will be in the result image. So post-processing is required. However, if we apply simple post-processing like rescaling, if we apply rescaling, the maximum should be 255, that is the rescaling. We'll have the exactly same images. There are no impact of enhancement. The another one is clipping. Clipping means if there are over 255, let's move on to 255. So you can see the white out. So it is also not good. So our proposal, we keep the detail of the information, but the range should be 0 to 255. That is our proposal. Then our proposal keep the shape of detail, but also the range is inside of 0 to 55. Mathematically, this is can be obtained by applying the range constraint. Here is a data term. The derivative of output image should be manipulated derivative. This is a kind of data constraint. And also we put the range constraint term. The input output image should be within 0 to 255. Then we will have then solving this equation, we will have this kind of good result. Maybe time is gone, maybe. So I will have some demonstration video, but today I'd like to skip this video. So if you have interest, please visit this YouTube. And also, again, okay, I'd like to conclude as follows. We've developed a gradient domain image processing. Then we'll have the good result very easily. And also we can, if we apply the low light image, we'll have good result. It might be good for the autonomous driving in night scene, for example. And the MATLAB code is available online. If you want, please visit this site. Thank you. That's all for today. Thank you for listening.
Okay, thank you, Professor Tanaka. Really interesting. So
now is, yeah, we have around 20 minutes for discussion. I can conclude that the advanced technology or control system, the basic of control system that Professor Yamakita and image analysis technique from Professor Tanaka, some is maybe already implemented in autonomous development or developing system and electric vehicle system. I think so. The topic today is all related with each other. I think we have to try to answer the question from the audience. So I think we can start from Dr. Meg. We have maybe 3 questions from the audience about emission control system. Dr. May can answer in each topic, or you can summarize for the answer.
All right,
we can have maybe 2 or 3 minutes for each professor.
Understand. Okay, I already checked the question. There is a question from Professor Kosaka and from Dr. Popo, and another is from Dr. Dittapum. All of them from Kosaka Laboratories, I think. So, and the questions are quite similar. So the main question is that I just read Professor Kosaka question. Do I have a data on effect of fuels on soot oxidation and morphology of soot particle generated from the biodiesel, the different effects, the oxidation of soot in the future? So yes, I understand that in Thailand, and also questions from Dr. Popo is about the same. So in Thailand, we are using the biodiesel as an alternative to the fossil diesel. And then effect of the particle emission generated from the biodiesel should be of interest. And but personally, myself, never done the research about the biodiesel before, because I spent a lot of time recently in Japan. But I just come back to Thailand, and but I can give you based on what I've reviewed the literatures, including the one done by Dr. Prisha, that the PM emitted from the biodiesel, as the since the biodiesels include of some oxygen contents, more oxygen contents as compared to the diesel. Therefore, the PM emitted from the biodiesel tends to have some oxygen molecule decorated inside of the particles, and also unburned hydrocarbon as well. And those oxygen molecule and hydrocarbons tends to make the PM emitted from the biodiesel combustion burn easier as compared to the PM emitted from the fossil diesel. But if I answer you as a public people, I would say yes, biodiesel PM burn faster, and it may result in a faster regeneration of the filter. But in deep science, still questions that whether we do the oxidation characteristic of the PM, whether the PM oxidation is exactly the same as the Dpf regeneration or not. That is a science and practical situation. So in conclusion, PM burn faster, but I'm not sure, 100% sure whether it will result in faster regeneration or not, since we never test, to be honest, the PM oxidation on the filter, comparing the biodiesel and diesel fuel. This is my answer to Dr. Popo and Professor Kosaka. And the answer to Dr. Dittapum, how about the regeneration at low temperature? I just, probably I was too hurried. I forgot to mention that the way we study the relationship between nitrogen dioxide and PM oxidation, we did it at relatively low temperature. than usual, meaning that around 250 to 400 degrees Celsius. So that that low temperature situation is quite favorable for the nitrogen dioxide to work. Therefore, I answer Dr. Dithapum that nitrogen dioxide's effects is good at low temperature, ranging from 250 to 400 degrees Celsius. This is all my answer. If you want more detailed information about the biodiesel, I think Dr. Prisha have more information. If you have something to add, just feel free.
Okay, thank you, Dr. May. I think is okay for the answer. Can I go to the next question? Can I ask Dr. Danai to give the answer from chat box? I think you have some answer in the normal chat, but in Q&A chat, I think not yet. If you have some additional, please, Dr. Danai. Oh, Dr. Danai is still in the room. Ajahn Danai, do you have any additional answer? Okay, before that, maybe we can skip to Dr. Manop, please, about electric vehicle and both electric vehicle. Dr. Manop, are you available for the answer?
Yeah, yes, I available, but I cannot open the camera. But I remain the one answer. But maybe I will give the answer to him. Yeah, a lot of answer to me, of more than 9. More than question to me.
Dr. Danai also joined. Okay, maybe after Dr. Manop, then Dr. Danai can have some additional, please.
Dr. Visha, I have to speak first.
Yeah, please, Dr. Manop first.
Okay, because a lot of question to ask me. For example, okay. So maybe Dr. Pisha can help me because a lot of I cannot read all of them. For example, if Thai company are not interested in the e-car market because of the FTA with China, how with the government push their goal to implement Thailand as a main EV hub for ASEAN? For the answer, you have to understand that the government push, but the problem is when the company invest some money, the company need the profit back. I cannot say the name company. For example, for the last 4 or 3 years ago, some company want to produce the e-car to sell in Thailand. After that, next year we have the FTA issue, and that time the company in Thai company stop to produce the car because they cannot win for the price of the car when because the duty tax 0%. Yeah, and also about the maybe the question. Okay. What area of the EV conversion are you currently researching? Will the Thai government support retrofit technology in the near future? Right now, the Thai government support many budget and for the research budget, and also for in the ECC, the Thai government support e-conversion for the pickup, because as you know, the pickup for the pickup body can stay more than 10 year, 15 year, and it means we can use the suspension or powertrain of the pickup, and then we just remove the engine, and then we put the motor and battery in the pickup car, and then we can use it again. Yeah, because the problem for the pickup, if you operate the diesel engine for the pickup in the city, the pickup can generate the PM 2.5, but if you try to convert from the ICE to the EV, you can reduce the PM 2.5 in Bangkok or in the city. And I used to ask the Toyota company why the Toyota company does not want to have the e-pickup, and he said, only one man said, give the answer to me. He said because of and for the pickup, Toyota pickup designed to carry the weight only 1 ton, but the Thai people use for the more than 2 or 3 ton to carry the weight, and it means if the Toyota has the product for the pickup, it means it cannot operate because of the Thai people like to use more than 1 ton or 2 ton. Yeah. Okay, another question to Dr. Manop. What do you think about the battery swapping system for the e-car to promote more user and buyer? We would apply membership for the battery to be leased as user by or own only the car body. The price of EV will be much cheaper. But for this, the answer, if you talk about the e-car and if you talk about the motorcycle, e-motorcycle, I think for the battery swapping should be suitable for the e-motorcycle because the battery pack is cheaper than. But if you talk about the if you talk about the battery pack for the e-car or e-truck, if you would like to use the battery swapping system, you have to understand that the price or the cost of the battery pack is more than 50% of the car. This means if you have the battery swapping, it means you have to spare part for the swapping about 2 battery for the 1 car. That it make the car is very expensive. Yeah.
Okay,
then,
Dr. Manop, I think the time is limited, so
okay.
Maybe if if the audience interesting in, you can contact Dr. Manop directly.
Yeah. Thank you.
Later. Can we skip to Dr. Danai, please?
Okay, thank you. And thank you for your question. For the first question is, when is Thailand preparing to commit autonomous vehicle technology in the industry, and how will they promote it? I think the market of autonomous vehicle is in the SAE level 3 or 4 in Thailand. It maybe start from the cross to service in the cross area, like industrial estate or in the some university which have a large area. That is a first step to promote in the to achieve the Thailand market. And the key global of automotive company or IT company planning to invest into the autonomous vehicle market of Thailand. I think that is also maybe saying that it starts from the service in cross area. So the communication from the vehicle and the map of the area is very important. So it requires the speed of communication between the car and the host server, that very important. Then I think the JuฬาUniversity case, they have the research to start the promote the smart city in the Juฬาarea, which includes the small autonomous bus in order to service in Juฬาarea and Siam Square. I think it will be you can see the business relative to the service or subscription of data for service is very important. Then it may require the 5G communication and the large bandwidth for communicate. And for the third question, does your research also consider the validation of topology and note whether the overall system comply with real-time requirements? This topic is very interesting for me because now I did not concern about this one, but I focus on to design the collaborative control between the some reinforced learning control or machine learning to work with the model-based control, such as feedback control or something like that, for safety in some situation which is never trained in reinforced learning or ML, because the model base is directly controlled, but if have more rigid, then it's make good for safety. Okay, maybe that's all for my question. Thank you.
Okay, thank you, Dr. Danai. I think normally now we have a TAIST-Tokyo Tech program that we have some research collaboration between Japanese professor and Thai University and NSTDA. I think we can both of Professor Yamakita and Professor Tanaka also give a lecture in Tokyo Tech program students. So if it's possible, we can have research collaboration with both our professors. It's a good opportunity, I think.
Okay, thank you very much.
Okay, Professor Tanaka and Professor Yamakita, do you have any additional information or comment on the workshop?
No, actually, my presentation was time limited, but I want to stress our method can be applied to the so-called connected cars. So in the future, actually the connected car is a very active research area. So maybe we can collaborate for the development of the connected car.
Okay, yes. Yes. How about Professor Tanaka?
As I mentioned, my application is already available online, the MATLAB version. if you have interest, please try. And then if you have any question, please ask me. And that is a maybe start point to future collaboration. That is a good chance. Thank you.
Okay, thank you very much. Okay, very good discussion. So maybe I will ask Professor Mitsukoshi come back to the room to give a closing ceremony.
Okay, thank you very much for the nice discussion. It is time to close the session. So as for the further discussion, please do not hesitate to contact to this address, Tokyo Tech Annex Bangkok. You can use Thai language and also English, and also to NSTDA to this address. So Dr. Prichakani, thank you very much for the chairperson, and I would like to thank to all the speakers today. And this event will be held regularly, so I will see you soon. So today, thank you very much for joining. Thank you very much.
Thank you very much. Okay, see you. Bye-bye.
Bye.
Thank you. Bye.
ขอบคุณครับ
ขอบคุณครับ
ขอบคุณครับอาจารย์